Hello everyone and welcome to the sampling video. I just wanted to take a moment and present a little video demonstration of the various sampling techniques and methods that you are reading about in your textbook. So without further ado, shall we begin? So sampling methods, the author is going to talk about four primary sampling methods. Actually, he does talk about five, and we will hit the last one towards the end of our discussion. The first one here is simple random sampling. Simple random sampling, I'll go into that in detail here in just a moment. A derivative of simple random sampling is called systematic sampling. And then another one is called clustered sampling. And then finally, we have what is called stratified sampling. One of the things that we are interested is to come up with a representative sample that represents the population. So these four are referred to as probabilistic sampling techniques. So to do that, to get a representative sample, these four techniques will help us out to do this. So sampling is one way of coming up with a collection of data. Another way of coming up with a collection of data is through what is called designed experiments. And we'll be reading about that later in our textbook. So let's take a look at each one of these in their gory detail. So simple random sampling assumes that we have access to the population, the whole population as a whole. So for example, if I'm interested in the annual salaries of registered nurses, I'm sure we can all agree that in the city of Denver, there are a lot of registered nurses. So let's just pretend that there's like 10,000 of them. So it's pretty unreasonable for me to think that I could go out and ask 10,000 registered nurses how much money they make per year. So what I could do is have access to the population, assign each registered nurse a number, and let's just suppose that I want 30 registered nurses. So I can go to a random number generator that says, hey, give me 30 random numbers from 1 to 10,000, and that will give me my population, that circle of people on the right-hand side of our picture. All right, so the idea behind the simple random sampling technique is that if your population has, say, size big N, then the probability that each subject is selected is 1 over N. So each subject in the population has an equal probability of being selected. So this will eliminate any sort of bias in the population that could be generated towards gender, towards race, towards socioeconomic status, towards religious preference, political preference, and so forth, because we have access to the whole population and we just randomly select through a random number generator. So that is simple random sampling at its best. And notice that I have over here my sample. It is representative of the population. And now I can just go ask these 30 nurses, hey, how much money do you make each year? And then based off of that 30 people, what they tell us, we can compute an average. And then later when we get to what's called inferential statistics, we can infer the mean of what these 30 people's salary is, and we can infer that across the whole population. Our next sampling technique is a derivative of the simple random sampling and is called systematic sampling. So systematic sampling, again, we have access to the population, all right? And if you'll notice over here on my sample, notice that I have the third person from the population, the sixth person, 9 and 12, and so forth. So the idea is that we have this starting point, and then we choose every kth person from the population. So if I had access to the population, you could put them in one big giant list, and then the idea is to get a starting point. So here I randomly select a starting point, say here at the number 3. I ask this nurse, how much does she make? Write that number down, go to the 6th person in the population, grab them, ask this nurse, how much does he make? Then I go to the 9th person, ask her, how much does she make? Go to the 12th person, ask her how much she makes. And I keep doing that for all 30. So this is systematic random sampling. And this is similar to the simple random sampling in that I have to have access to the whole population. And that might be a unrealistic assumption, but this is the idea if we were to perform this. So the idea is, suppose that you work at a manufacturing company, and suppose you work for Coca-Cola, and the idea is that the soda dispensing machine should be dispensing 12 fluid ounces of Coca-Cola into the can. But it has been determined that it is acceptable that 11.9 to 12.1 fluid ounces in the can is acceptable. So it has been determined that you will choose every 50th can of Coke and measure the amount of Coca-Cola in that can. So the assembly line starts coming down, you grab the 50th one, you weigh its contents, you put it back in, you grab the 100th one, you weigh it, you put it back into the assembly line, and you keep doing this for your whole shift. The idea here and the recognition is that with systematic sampling, it's grabbing every kth unit. Okay. So our next sampling technique is called cluster sampling. So on the left side of the picture here, you can see that the population is put together but can be put into groupings. And if you take a look at the groupings, notice that they're kind of, we have a white and a black, a gray and a black, gray and a black, 2 black. And notice the idea is that each one of these 6 clusters, all right, has a difference in it. We call this heterogeneous, meaning that the clusters, they're unsimilar. So if you kind of think about the city, the metropolitan city of Denver, the whole metropolitan area, there are certain neighborhoods where one neighborhood would be predominantly black, one neighborhood would be predominantly Asian, one neighborhood would be predominantly Hispanic, and so forth. But they may be predominantly this way, but there's also a mix of the races, if you will, in those 2 neighborhoods. So the idea is that the population is broken apart, and in each piece, in each cluster, they're different. There's a difference in the population. So then the idea is that you pick a subset of clusters, and notice here in this picture we have this one chosen and this one chosen, and then we do a little random sampling in here. So we chose number 5 and 6, and then here we chose this cluster and we brought these people over. So these 2 clusters here will form the sampling. So the idea here is when you choose a cluster, you go into that whole cluster, and one thing you can do is sample all the samples or all the subjects in each cluster, or you can do a little simple random sampling that is occurring. So let's take another look at a practical example here. So in this example, we have that the mayor of the city of Denver is interested in whether or not the city of Denver should be a sanctuary city. So he is interested in taking a look at the citizens in the city of Denver, but the city of Denver is really huge, but the city of Denver can be broken down into these city 78 neighborhoods. So what has been determined was a sample size of 200 is wanted. And so what we'll do is we randomly select each one of these clusters. So each neighborhood forms a cluster. So when we randomly select from the clusters, we come up with these neighborhoods right here. So one of the things we can do is we can go into each cluster and ask everybody, hey, do you think that the city of Denver should be a sanctuary city? Yes or no? And then move on. Or you could do a little simple random sample. In this case, you can randomly select, using the simple random sampling technique, 10 citizens, go in there and then ask them. So there's a couple of different ways that the cluster sampling within the clusters can be done. So again, the idea with cluster sampling is that the population is broken apart and you randomly select clusters and then you go in and sample within each cluster. Stratified sampling is one of our last ones here, and again, the idea is that the population can be broken apart into what we call homogeneous strata. So each one of the strata are similar. So notice that on the left here, our population, we have white, we have black, and we have gray. Okay, and notice that within this strata, everybody's similar, and in this strata, everybody is similar, and in this strata, everybody's similar. And notice the idea is that if I come to this first strata, I just do a little simple random sample, and here I choose subject number 10, goes in there, and then notice in this strata, we choose 2 people, or 2 subjects, if you will, and we bring them over here to our sample, and then finally we come down here and grab 1 person. So notice the white and the gray both have 1 subject, and the black has 2 subjects. So why is that? And the idea with the stratified sampling is we can implement this thing called proportional allocation. So if strata 1 has the largest number of subjects in it, then stratas 2, 3, and 4, then it would make sense to have a larger part of our sample coming from strata 1. And then if strata 2 has the next amount of subjects in it, then we would want to sample more from strata 2 than from stratas 3 and 4. And then if strata 3 was the next highest, we would want to sample more from strata number 3. So that's the idea of this proportional allocation. So students in the dormitories at some university in the state of Colorado, they live in these dorms, and somebody at the institution is interested in whether they approve of the President Trump's border wall legislation. So we want to sample 24 students from this college that live in the dorms. So notice that in the dorms we have freshmen, sophomore, junior, senior, and notice there's 128 of the freshmen and 112 of the sophomores and so forth. So the idea is to implement the proportional allocation. We would want to sample more from the freshmen because in the population there are more freshmen than there are the others, and then work our way down. So to proportionally allocate, we can note that if we add up the number of residents, that should be 384. So notice 128 divided by 384 says we should get about 33% of our sample. So this says at the end of the day, 8 people come from freshmen, 7 from sophomore, 6 from the juniors, and 3 from the seniors. So I go to the freshmen, those 128 freshmen, I do a little simple random sampling, say, give me 8 freshmen from 1 to 128, and I randomly select those 8, and then I repeat the process for the sophomore, juniors, and the seniors. Just to put some closing comments regarding the difference between stratified and cluster sampling, let's just note that all strata are represented in the sample. So notice that we sampled a little bit of freshmen, a little bit of sophomores, juniors, and seniors. But in the cluster sampling with the neighborhoods, we only randomly selected a subset of 20 of the clusters out of the total of 78. So not all clusters are represented, but all strata are represented. And then the next thing is with stratified sampling, it's best when, again, there's this internal homogeneity within each of the strata. So we would think that freshmen would probably think similar regarding building a wall along the border. And we would think that juniors, sophomores, and seniors would also think similarly within the strata. However, cluster sampling, within each cluster, they are broken up a little bit. And finally, just to put a little spin on our little discussion on convenient sampling. Convenient sampling is pretty much what it says it is. You, the pollster, you just go out and whoever's there, whoever's there, you just ask them the question. So suppose that you're interested in the average age of the student body at Front Range Community College for a particular semester, and you're walking down the hallway and you just walk up to somebody and say, "Hey, how old are you?" And they tell you, and you keep walking and say you need 100 ages. So they're there. Notice it's not random. It's not any sort of probability sampling technique that you are implementing. There is no randomness. It's just whoever's there that you ask. All right, so remember, simple random sampling says you have access to the population, you assign a number to the subjects, and then you randomly select from those numbers from a random number generator. Just randomly walking up to somebody is not a simple random sample. That is a convenient sampling. So got to make sure that we easily understand the difference between convenient sampling and simple random sampling. So that's sampling techniques in a nutshell, and I hope this video helps you out.